Good evening, everyone. This is Ivy Baliter from Science 3B. So, our discussion is about cytoskeleton and their function. This will be discussed by me and my partner, which is Julie Arsenwe. So, the main objectives here is for the student is to identify and describe the three main types of cytoskeletal filaments, which is the microtubule, microfilaments, intermediate filaments, and their structural characteristic. Also explain the rules of the cytoskeleton in maintaining cell shape and mechanical support. Describe the function of motor proteins, kinesin, dennin, mucin, and intracellular transport and organelle positioning. Understand the role in the cytoskeleton and cell division, mitotic spindle formation, and describe how the cytoskeleton facilitates cell movement like cilia, flagella, and amoeboid movement. So, before we proceed to our main discussions, we were going to define the cytoskeleton first. What is cytoskeleton? Cytoskeleton, it is the dynamic network of protein filaments and tubules in the cytoplasm of many living cells, giving them shape and coherence. So cytoskeletons are found in the cytoplasm, which is all the living cells, all the cell in the cytoplasms are the cytoskeleton are the one who gave them shape. Then there are three components of cytoskeleton, which is the intermediate filaments, microtubule, and the microfilaments. Let's define first the intermediate filaments. a type of a type of cytoskeletal filament known for its tensile strength and ability to resist mechanical stress, providing structural support into cell and tissues. So, meaning to say, in these intermediate filaments, it is they have the ability to resist mechanical stress in order to provide support to cell and the tissues. So in a microtubule, it is hollow cylindrical structures made of tubulin protein, serving as a drug for motor proteins. When we say motor protein, it is involved the kinesin, dennin, and the mucin. Motor proteins forming the mitotic spindle and providing structural support. And the microtubule, this is the process on how to form the mitotic spindle. And the last one is the microfilaments, which is the actin filaments. Thin, flexible protein, which filaments made of actin. So, the microfilaments, it is the flexible. Then, involve the cell shape, muscle contraction, cell movement like amoeboid movement, and the cytokinesis, which is the cell division. So, and the microfilaments involves the cell division. And motor proteins like kinesin and mucin, dennin are the are used and are use energy from ATP hydrolysis to generate mechanical force and move along cytoskeletal filaments, enabling intercellular transport and cell movement. So let's define kinesin first. Kinesin is a motor protein that typically moves along microtubules, meaning to say the kinesins found in the microtubules, often transporting vesicles and organelles away from the cell center. So, the role of the kinesin here is to transport the organelles and the vesicles away from the cell center. Then the next motor protein, which is the dennin, it is a motor protein that moves along microtubule, typically transport vesicle and organelle towards the cell. So when we say kinesin first, it is to transport vesicle and organelle away from the cell center, while the dennin, it is to transport vesicle and organelle towards the cell center. So they are the differ they are the difference that are the difference of kinesin and dennin. The last one, motor proteins, involve mucin. When we say mucin, it's a motor protein that interacts with actin filament. So the mucin, it is the protein who interacts with the actin filament. It is also responsible for muscle construction, muscle cell shape changes, and the cell and various forms of cell movement. So in the mucin, this is the cell shape changes happens in cell shape changes and cell movement. So the intracellular transport and organelle positioning will be discussed by my partner.
Good day everyone, this is the continuation of our lessons, Cytoskeleton And Function. Next is intracellular transport organelles positioning. It refers to the movement of molecules and organelles within a cell. This crucial process is facilitated by the cytoskeleton, acting as a network of tracks and motor proteins which act as the vehicles that carry current. So the next is cytoskeleton and their cell series include mitotic spindle. So mitotic spindle structure formed by microtubules during cell divisions include mitosis in meiosis that segregates chromosomes to opposite poles of the cell. So the next is cell movements include cilia, flagella, and amoebots movements. First is cilia, as short hair-like appendages on the surface on many cells, composed of microtubules used for locomotion or moving substance along the cell surface. Second is flagella, long whip-like appendages found on the surface of some cells composed of microtubules used for locomotion. The lastly is amoeba, movements are types of cells motility in which the cells change shape by extending projections called pseudopods driven by the dynamics assemble of actions of myosin. That's all for our discussions about cytoskeleton and function. I hope that you learned and thank you for watching.